Hello, Sotiris Pelekis from NTUA, and I will be presenting the ABS component, which is the outcome of the research that corresponds to tasks 5.3 and 5.4. The main functionalities of the ABS component are to offer the Sphinx user a testbed that allows them to define arbitrary network topologies that resemble to the existing ones in hospitals. Furthermore, it permits the reproduction of realistic network traffic conditions in a controllable and scalable manner. Finally, it allows the examination of the system's responses against cyber attacks, and specifically DOS attacks at this stage, which fall within the scope of use case 7. Proceeding to architectural concepts, custom Docker bridge networks are being utilized given that they provide a certain degree of isolation. Containers are able to initiate connections, exchange data flows, and perform cyber attacks, supervised by a central container which also provides the graphical user interface of the ABS. The present topology, which is very similar with the one to be examined during the demo, is very representative of the ABS architecture. Two containers emulate TCP and UDP servers and clients that exchange normal traffic, while an attacking container is able to perform DOS attacks. All of these operations are orchestrated by the Sphinx user through the ABS front end. In terms of current status, during the development of the Sphinx ABS component, various statistical methodologies and relevant tools have been examined and deployed for realistic hospital traffic fitting and generation. Considerable research has been devoted to topology emulators that provide APIs for the creation of custom network topologies, along with emulation frameworks for normal user behavior patterns. Finally, in the context of cyber attacks, extensive research has been conducted on relevant frameworks and operating systems in order to provide the Sphinx user with a variety of safe options to experiment with network attacks. Other types of attacks are also being investigated and are planned to be included in the ABS portfolio. These are some of the main tools used throughout the development. And now we can proceed to the demo. This is the front end of the ABS application. In this menu, the user is prompted to select the statistical parameters of the on-off traffic that's intended to be exchanged as normal traffic between the nodes of the network. Let us stick here with the predefined parameters and submit the tuned traffic. We can then proceed to the corresponding on-off traffic management menu, and we can declare the two nodes as sender and receiver. These nodes already exist in the Docker network with those names. And then we can just select one of them, for example, the sender, assign the traffic that we just created, and assign it to be sent to the sender. We can add it, as we can see here, and we can schedule it to be sent. By sniffing the receiver interface here, we can observe that it's constantly receiving the scheduled TCP traffic. So at this point, we can proceed to a DOS attack implementation. Let us target again the receiver node with the UDP flooding attack, and target specifically the port that is already receiving the TCP traffic. We can now see that the receiver is receiving unwanted UDP traffic from random spoofed IPs. We can also observe that the receiver's network traffic memory starts to increase excessively, which is not at all a desired behavior. In this way, the Sphinx user becomes aware of the system's responses against possible cyber attacks in a safe experimentation environment. And that's all from my side and the ABS component. Thank you.